Marine freshwater estuarine reservoir and cold water fisheries of India. Fish culture, nutritional requirements of carps, Siluroids and Murrels, carp cultivation in India. Spawning, collection, hatcheries, rearing, shocking, transport and mortality of fish fry. Introduction. India is a land of diverse aquatic ecosystems that support a wide array of fish species, contributing significantly to global fish production. Fisheries and aquaculture play a pivotal role in national food security, nutritional requirements, rural employment, and economic development. The fisheries sector in India encompasses marine, freshwater, estuarine, reservoir, and cold water systems, each offering unique resources and requiring specific management strategies. Marine fisheries in India. India's marine fishery resources extend over a coastline of 7,517 kilometers, with an exclusive economic zone (EEZ) of 2.02 million square kilometers. Marine fisheries are primarily concentrated in coastal states such as Gujarat, Maharashtra, Kerala, Tamil Nadu, Andhra Pradesh, and Odisha. This fishery can be broadly classified into artisanal, mechanized, and deep-sea fisheries. Marine fishery resources include both pelagic and demersal fish species. Pelagic fishes like Indian mackerel Rastrella dracanagurta, sardines Sardinella spp, and tuna inhabit surface waters, while demersal species such as croakers, pomfrets, and catfishes dwell near the seabed. Crustaceans like prawns Peneus spp, and lobsters and mollusks like cuttlefish and squids also form an important component. Fishing techniques vary from traditional catamarans and dugout canoes to mechanized trawlers and purse seiners. Sustainable practices are now promoted, including seasonal bans and marine protected areas (MPAs), to address overfishing, bycatch issues, and habitat degradation. Freshwater fisheries in India. Freshwater fisheries form the backbone of Indian aquaculture. Rivers, reservoirs, lakes, ponds, and tanks serve as major habitats. The Ganges, Brahmaputra, Godavari, Krishna, and Kaveri are among the major riverine systems supporting inland fisheries. Indian major carps IMC, Katla, Labio rohita, and Sirinus mergla are the predominant cultured species. Exotic species like common carp, Cyprinus carpio, silver carp, Hypophthalmicthes molitrix, and grass carp, Tenepharingodon idella, have been successfully introduced to increase yield. Culture systems range from extensive low input, low output, to semi-intensive and intensive systems involving supplemental feeding and fertilization. Integrated fish farming systems involving agriculture, duckery, and piggery enhance resource use efficiency. Estuarine and reservoir fisheries. Estuarine fisheries thrive in brackish water ecosystems, such as the Sundarbans, Chilika Lake, and the Vembanad estuary. These ecosystems support species like mullets, pearl spot, Etroplus suritensis, mud crabs, Scylla spp, and various shrimp species. Brackish water aquaculture is dominated by shrimp farming, particularly Peneus monodon and Litopeneus vaname. Mangrove ecosystems also support artisanal fisheries and act as nursery grounds for juveniles. Reservoir fisheries utilize man-made impoundments for fish production. India has over 19,000 reservoirs, varying in size from small to large. The fishery is primarily based on stock enhancement and capture of IMCs, minor carps, and catfishes. Cage and pen culture are gaining popularity for their intensive production capabilities. Effective reservoir management includes regular stocking with quality fingerlings, habitat improvement, enforcement of fishing regulations, and community participation through fisheries cooperatives. Cold water fisheries in India. Cold water fisheries are restricted to the Himalayan regions and high-altitude terrains in states like Himachal Pradesh, Uttarakhand, and Jammu and Kashmir. These fisheries are characterized by low water temperatures, high oxygen content, and clean, fast-flowing streams. Key species include rainbow trout Oncorhynchus micus, brown trout Salmotrida, snow trout Schizothorax spp, and golden masser Tor putatora. Trout farming is carried out in raceways and flow-through systems, where water quality is stringently maintained. Cold water aquaculture faces challenges such as limited suitable sites, low reproductive rates of native species, and climatic constraints. However, high market value and ecotourism potential make them a priority for conservation and development. Nutritional requirements of cultured fishes. Proper nutrition enhances growth, immunity, reproductive performance, and overall health in aquaculture species. Carps. Carps are omnivorous and require 25 to 30% crude protein, 5 to 7% lipids, and a carbohydrate-rich diet. Essential amino acids, such as lysine and methionine, are limiting in plant-based feeds and must be supplemented. Micronutrients such as vitamin C, ascorbic acid, support skeletal development and stress resistance, while minerals like calcium, phosphorus, and zinc are important for bone development and metabolic processes. Carps are commonly fed rice bran and oilseed cakes in traditional systems. In commercial systems, formulated pelleted feeds containing soybean meal, fish meal, maize gluten, and vitamin-mineral premixes are preferred for consistent growth. Siluroids, catfishes. Catfishes like Clarias batrachus and Heteropneus fossilis are carnivorous and demand a high-protein diet, 30 to 40%, with adequate lipids, 8 to 10%. Fish meal and animal protein sources are important in their diet. Catfishes benefit from high-energy diets and require taurine, carnitine, and omega-3 fatty acids for optimal performance. Murrels, snakeheads. Murrels such as Canis striata are carnivorous and require a protein-rich diet, 40 to 45%, and 8 to 10% lipids. Initially dependent on live feed, insects, small fishes, murrels can be weaned onto formulated floating or sinking pellets. Use of attractants and feeding stimulants helps during the feed transition phase. Carp cultivation in India. Carp farming involves a comprehensive set of practices aimed at optimizing survival, growth, and production. Spawning. Natural spawning in wild rivers during the monsoon season is erratic. Induced breeding is preferred using hormonal injections, hypophysation. Pituitary gland extracts, Ovaprim, GnRH analogs, and HCG are commonly used. Fish are conditioned in breeding tanks with proper temperature, 24 to 28 degrees Celsius, and aeration. Collection of eggs and hatchery management. After fertilization, eggs are transferred to hatching units, such as Chinese hatcheries or glass jar hatcheries. Gentle water flow and oxygenation are critical. Eggs hatch in 12 to 24 hours, and hatchlings are moved to nursing hoppas or tanks. Rearing of fry and fingerlings. Nursery ponds are prepared by liming, 200 to 500 kg/A, fertilizing with cow dung and urea phosphate to promote plankton growth. Fry are stocked at densities of 2 to 5 lakh/A. Feeding begins with finely ground feed mixtures. After 15 to 30 days, fingerlings are transferred to rearing ponds and grown to a stocking size of 80 to 100 millimeters. Shocking and acclimatization. Before stocking in grow-out ponds, fingerlings undergo shocking or acclimatization to adjust to new temperature and water parameters. This process involves gradual mixing of pond water and transport water to prevent osmotic shock. Transport of fry and fingerlings. Transport is done using polythene bags filled with oxygen and water or specialized transport tanks with air nutritional requirements of cultured fishes. Proper nutrition enhances growth, immunity, reproductive performance, and overall health in aquaculture species. Mortality and its prevention. Mortality can result from handling stress, poor water quality, ammonia, nitrite, predation, or diseases, bacterial, parasitic, fungal. Preventive measures include prophylactic treatments, e.g., potassium permanganate bath, maintenance of water parameters, use of immuators. Use of anesthetics like MS-222 reduces stress. Antifungal or antibiotic treatments minimize post-transport mortality. Conclusion. India's fisheries and aquaculture sector is diverse and rapidly evolving. Understanding of the intricate details of each aquatic ecosystem, nutritional physiology, and practical culture techniques is essential.